we're going to cover just the last part of this first Unit 0 kind of properties of exponents. So I'm actually going to call it 0.3b. It's the second part of the last one that you did. And again, put a date on. And when you're done with these notes, show me, and it's your ticket to your worksheet. Our question is, the properties of exponents get used most of the real world in science, and it's used in science. They're used in scientific notation. So our goal today is going to be how do I move between what I'll call regular notation, which is what most books actually call it standard, but regular notation, and you might say I have no idea what that means. What I mean by regular notation for a number is just how you would normally write it. Like if I said write the number 50,000, that's called standard notation or regular notation, and we want to be able to move between that standard notation and scientific notation. It's generally pretty easy task to move in and out of scientific notation. So I think what we'll do here is we'll just make ourselves a little chart and discuss how we move between the two. So on this side, let's write standard. I think most books will call this standard notation. Now I'll slow down here and let you get that written. So we're going to make a little chart where we're going to put standard notation on one side, and then let's draw a bar here all the way down, I think. And on the other side, we're going to put our number in scientific notation. The first thing you need to know about scientific notation, and I'll pause, I'll let you get, I'm sorry, I'm writing really fast, so I'll let you get that written down. So our goal is going to be to move between the two notations for numbers, standard notation and scientific notation. The reason we do this is because when things get really, really, really big, or extremely small, they become tedious to write in standard notation. And that happens in science a lot with like atoms and nuclei and electrons and protons and all those things that are so tiny, and bacteria. And it's also used in like astronomy for distances, because from here to Mars is an incredibly big distance and an incredibly large number. So you'll see those really large and really small numbers written in scientific notation. So our goal is going to be to move between the two. What I want you to write over here is the format for scientific notation, because scientific notation has to meet some criteria to really be in scientific notation. First of all, there's some number out front, and I'm just going to call that n. That number has to be, go ahead and point in a little arrow, between 1 and 10. And it can't be 10. It can be 9.999999999, but it can't be 10. And scientific notation uses the old-fashioned notation for multiplication. It's one of the few places that, beyond elementary math, that you actually see an x 4 times. They don't use a dot because it tends to get confused with a decimal point, which we have in scientific notation. So we have some number between 1 and 10 times 10 to some power. So that's what our answer over here in our scientific notation needs to look like. So in order to figure out our number, what we do is we grab the decimal point. And if you don't see a decimal point, like if I said, how old are you? And you wrote down the number 16, well, that decimal point is at the end. You just don't say, well, I'm 16.0 years old. It sounds ridiculous. So when you have a whole number like 5 or 6 or 7, there is a decimal point, but it's at the end of the number. So when I have the number 50,000, there is a decimal point. It's just you don't see it. It's right there. So what I want you to do is consider the decimal point right there at the end of the number, and you're just going to scoot that on over to the left until you get this number between 1 and 10. So I'm just going to move, basically what I'm doing is I'm dividing by 10 and I'm scooting that decimal point over. And I'll stop right at 5.0, because if I go one more I get 0.5, and that's less than 1. So I stop between those first two numbers and I say 5, and you can write 5.0 if you want, but because it's all zeros, that's not necessary. 5 is my number between 1 and 10, and then I say times 10 to the, and I just count how many places I move the decimal. On this one, it was 4 places, so I do a positive 4. Now, what tends to be a problem with scientific notation is really not the number out front. That's easy to find, and the times 10's in every scientific notation answer, so you can't really get that wrong. But knowing whether to use a positive or a negative exponent sometimes goofs kids up, and I'll just tell you the easy way to determine which one you use is if you have a really big number, like 50,000, you should have a big exponent. So I wouldn't use a negative 4. That's the easiest way just to remember it as big numbers, big exponents. So let's go take another big number. Let's make it 39,200,000. The bigger the numbers get, the more often you would see them in scientific notation. Again, these two numbers aren't gigantic, so I'm fine writing 39,200,000, but if it were 3910 billions, and I'm trying to work with that in science, that's hard to work with. So what I do is I convert it into scientific notation. I grab that decimal point, which is at the end of the number, and I go 1, 2, 3, 4, 5, 6, 7 places. So I say my number is 3.92. You write it until it goes all zeros. So I need the 9 and I need the 2. Once you hit zeros, don't write them. So I'd have 3.92 times 10 to the, and I move that 7 places. And I have to decide positive 7 or negative 7. Big number, big exponent. Now let's try going the other way. Let's take a really tiny number and put that number in scientific notation. I do exactly the same thing. I grab the decimal point, which I can see, and I just start scooting it on over here till I get a number between 1 and 10. That's 0.12 or 12 hundredths, too small. Right there, 1.2. If I go one more, I'll be at 12, and I'll be outside of these boundaries. So again, I need that number to be between 1 and 10. So I'm going to stop when I get that 1.2. I'm going to write 1.2. And then I'm going to always have times 10. And then how many places did I move that decimal point? Well, I forgot, so I got to go do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. But you don't write times 10 to the 9th because this is an incredibly tiny number. I write 10 to the negative 9th. One more of those. Going into scientific notation. Let's do another one, 0.00439. If I were to convert this to scientific notation, I do a scoot, and I stop, because 4.39 is between 1 and 10. If I go farther, I'm at 43, and I'm outside those boundaries. So I get 4.39 times 10 to the, how many scoots did I do? 3. So what's wrong with this? You should know. What's wrong with it is that was a very tiny number, and I want to make sure that I use that negative exponent. And so be careful with your positive versus negative exponents. So now what we're going to do is we're going to reverse that. I'm going to give you a couple numbers that are in scientific notation, and you're going to get them out. The first number I'm going to give you is a number between 1 and 10. So I'm going to say 8.9 times 10 to the, and I'm going to put a positive power on here. That positive power means I need to move that decimal 5 places, and I need to move it to make it bigger because that's a positive exponent. It means I multiply by 10 5 times. And every time you multiply by 10, you might have learned, well, I add a 0. Actually, you move the decimal point over. So I need to take that 8.9 and move the decimal point over 5 times. What it'll take me 1 just to get to here. So what I need to do is tack on enough zeros to get up to 5. So I've got one move right here, and then I've got to go 1, 2, 3, 4, 5. So, and then you put your comma every 3 in from the right-hand side. So if you kind of take a look at it, I've got my decimal point right here. I scoot it on over. I'm going to write it right below it to the end once, and then I go 2, 3, 4, 5, and I fill every hole with a 0 if you like to do it that way. So now we'll do one that's negative, and we'll be done. I'll give you one to try on your own maybe. So I'm going to go I'm going to call my number, let's say, scientific notation. Let's say it's 1.09. That's a number between 1 and 10, times 10 to the negative 7. What that means is, again, those negative exponents mean you divide by 10 7 times. It's going to make it very tiny. And every time we divide something by 10, we move the decimal point 1 to the left. So I'm going to take and move the decimal 7 places to the left. It takes me 1 just to get to the end of the number here. So I'm going to have to put 6 zeros in front of that. So watch, 1, 2, 3, 4, 5, 6, and then I have to write the 109. Now this is wrong over here. This is a common mistake I see. Watch this. I don't have a decimal point and I need one. So make sure when you move that decimal point over, and I'm going to write it right below, it was 1.09 and I'm scooting it to the left. 1, 2, 3, 4, 5, 6, 7 places. Make sure you put that decimal on there, and then we fill every hole with a 0. So make sure you get a decimal on there. So what I'd like you to do is 2 of these and then come show me. If they're right, I'll have you work on the homework for this. So I'm going to have you put this number into scientific notation, and I'm going to have you take this number and take it out of scientific notation. And when you have that, come and show me, and we'll be done. I'm not going to put a summary on this lesson. All right, so that's the end of this. What you will be doing next is taking a little quiz on 010203. Before you do that, I'm going to give you a little I'll just ask you some questions before I give you access to that small test. All right, over and out.